In the last video, we parameterized a polar curve, r equals -4 cosine theta, into x and y values, so that we could find dy dx. Remember that dy dx is what we use to find the slope of a tangent line. So now we're going to take the next step in the process and try to find the second derivative, the rate of change of the rate of change of y with respect to x. So we'll take a look at this. We're going to have to obviously take the derivative of the derivative. Perhaps it might be nice to simplify this a bit. So before we jump into it, we'll go ahead and distribute the negative into here and reduce the 4/8 to 1/2. So that's going to change that negative sine squared to a positive sine squared, change the positive cosine squared to negative cosine squared. And the 4/8 reduces to 1/2. And I'll do sine first and cosine second. Why not? All right, so that is the same thing. That's our first derivative. So now we can take the derivative of our derivative. So we'll go ahead and do that down here. This is obviously going to be a chain rule problem. So if dy, I'm sorry, also chain rule, but I meant quotient rule. If dy dx equals u over v, then d squared y dx squared is going to be u prime v minus u v prime over v squared. So this is going to get pretty messy. I think it might be best if we actually figure out these pieces separately. So we know that u starts out as sine squared of theta minus cosine squared of theta, which means that u prime is equal to 2, power rule, times the sine of theta, because the argument doesn't change, but the chain rule says multiply by the derivative of the argument. So that's a cosine, right? Derivative of sine is cosine. And then minus, power rule brings that 2 out front. The argument of cosine of theta doesn't change, but then we multiply by the derivative of the argument, multiplying by negative sine of theta. So change that double negative to a positive, and then we'll just put a sine of theta here. So u prime equals 2 sine theta cosine theta plus 2 sine theta cosine theta. That's 4 sine theta cosine theta. All right. Similar sort of problem with v. V is 2 times the sine of theta times the cosine of theta. So v prime is 2 times a product. Sine of theta differentiates to cosine of theta. So u prime v plus u, and then v prime is going to be negative sine of theta. All right, so that's going to give us 2 times the cosine squared of theta minus the sine squared of theta. All right. Now I'm noticing that this is the sine squared of theta minus the cosine squared of theta, so I'm going to think ahead a little bit, and I'm going to say, well, it might be nice if they matched. You don't have to do that, but it might save you a little bit of headache later on. So if I factor out a negative here, then I'll factor out that negative, put it in front of the 2, and get sine squared of theta minus cosine squared of theta. All right, so that's u and u prime and v prime, so I can include those in our quotient rule. The other thing to remember is that these are all derivatives with respect to theta, but we're actually taking the derivative with respect to x. So that's that extra little bit of chain rule that we have to remember. So we've got the derivative, the d squared y dx squared is equal to the derivative with respect to x of dy dx. So if we're taking the derivative of these guys with respect to theta, we're done. But if we're taking these derivatives with respect to x, then we have to remember to multiply by dx d theta. In other words, divide by d theta dx. That's, again, that same piece that we talked about back with the parametrics. All right, so anyway, u prime v minus u v prime. So we're going to get 4 sine of theta cosine of theta. 4 sine of theta cosine of theta times v, which is 2 sine of theta cosine of theta. That's my u prime v minus u v prime. Well, u was equal to sine squared of theta minus cosine squared of theta. Sine squared of theta minus cosine squared of theta. And then v prime is negative 2 times the sine squared of theta minus the cosine squared of theta. So times a negative, it's going to be negative times negative, so that's going to change that negative to a positive. I'll have the 2. And then a sine squared of theta is multiplied by, right? Theta minus cosine squared of theta. That's my u prime v minus u v prime all over v squared. So that's 2 sine of theta cosine of theta squared. But don't forget the chain rule, so that's going to be times dx d theta. In other words, divided by d theta dx. All right, so let's see what this simplifies to. We've got 4 times 2 is 8. Sine times sine is sine squared. Cosine times cosine is cosine squared. So that's the first term in the numerator. The second term, well, notice that we've got a factor of 2. We've got 2 factors of sine squared of theta minus cosine squared of theta. In the denominator, we've got 2 sine of theta cosine theta squared. And then we also have d theta d. Wait a second, I got that backwards, didn't I? dx d theta is what's going to go in the denominator. This is d theta dx on the top. Oops, my fault. Because we're taking the derivative with respect to x. So we're multiplying by d theta dx, which means we're dividing by dx d theta. And if we recall, way back in the last video, we found that dx d theta was equal to 8 times the cosine of theta times the sine of theta. 8 times the cosine of theta times the sine of theta. 8 times the cosine of theta times the sine of theta. My goodness, that was a mess. Now we could probably go through this process and simplify a little bit more, but I think I'm ready to actually answer the question. It asks us to find d squared y dx squared and then evaluate it. That's the bigger question, is can we actually evaluate this at 3 pi over 4 and get a numerical answer? So let's go ahead and do that. We'll do d squared y dx squared evaluated when theta equals 3 pi over 4. Now remember that we're going to get the square root of 1/2 for sine, and we're going to get the negative square root of 1/2 for cosine. So that's going to, if we think about it in terms of that, it's going to make things a little bit easier because when we square either one of those, we get 1/2. And when we square here, we get 1/2 as well. And we're subtracting 1/2 minus 1/2. So that's actually going to be a fairly nice simplification. And then down here on the bottom, we get 2 times the square root of 1/2 times negative the square root of 1/2. So that's going to be negative 1/2. And then we'll square that. And then we've got 8. Yeah, 8 times the negative square root of 1/2 times the positive square root of 1/2, so that's going to be negative 1/2. Alrighty. So a lot of things simplify out here. First of all, this just goes away, this whole thing, because it's 2 times 0. And then the 8s can cancel out. Well, let's not do too much at once. Let's just go ahead and do that, right? Because the minus 0 or plus 0 doesn't matter. This is going to be negative 1/2 times 2 is negative 1. Negative 1 squared is 1. And then this is just going to be 8 times negative 1/2. Now the 8s can cancel out. And we get 1/2 or 1/4 divided by negative 1/2, which is working out to be negative 1/2. Holy for holies, that was a lot of work for a number. Now my question is, does negative 1/2 even make sense? Remember that the second derivative of y with respect to x is the concavity. So a negative 1/2 does make sense, because if you think way back to what we were doing at 3 pi over 4, our theta value of 3 pi over 4, we found that that slope was 0 because if we go all the way back to the graph, all the way up here, that was this top point of this circle, right? And the top point of the circle has a negative concavity because the top half of this whole circle is concave down. So that does make sense. And I'll leave this with you. What would happen if we had remembered our double angle identities? I challenge you to do the same problem, but reduce this a little bit further using double angle identities, this first derivative. And that way we can actually avoid a whole lot of this mess. And it's a great activity. It'll review some important trig identities for you. And you already know what the answer should be, so that's a great thing to try. See if you can do that and end up with the same answer of -1/2.